Okay, so the continuation of this lesson looks at another concept relating to lines, and it's all about gradient, or the slope of the line. And gradient is something that's used really commonly, and we can use it for lots of different things, but let's just get the concept down first. So gradient is calculated using a particular formula. It's called m in an equation, so you might have seen the line form y equals mx plus c. The m in that case means gradient. And it's calculated by doing rise over run, and I'm going to show you what that looks like. So it's found by working from left to right, and you do the run first and then you do the rise. So let's do it using these two graphs that we've got here. So what we need to do is select any 2 points that the line falls on, and we're going to find how far along one point horizontally one point is from the other. So that's our run. Run is horizontal movement, and it can be in the positive or the negative direction. And rise is obviously upward movement, but it also accounts for downward movement in this case, but it's the vertical movement that we're working with. So I'm going to work on this point and this point. You can pick any 2 points. So select any 2 points and find out how much the line has moved in both the horizontal and the vertical direction. So literally that's what we're going to do, and we can use that to work out the gradient, which is really awesome because it has lots of applications, which we'll show you over the next few lessons. So in this case, we want to do the run first. So that means how far it's traveled horizontally. So we start here, we move 1 place, 2 places. So we've moved 2 places. Now, something to note, movements that are towards the right and upwards are considered positive. So think number lines when we're thinking to the right. So when we move towards the right with a number line, that's the positive values. Movements that are left and downwards are considered negative movements. So up and right positive, down and left negative. So think number line when you're thinking that, to hopefully remember it. So our run is 2 places in the positive direction, so run equals 2. Now the rise is calculated from where you just finished up, so we're going to move upwards. Now note that each one of these values is actually 2, 4, 6. So that means we've moved up 1, 2, 3, 4. Our rise in this case is 4 because we moved up 4 places on our axis. So now we've got enough to calculate our gradient. Rise over run, 4 over 2, and of course simplify down to 2. Notice we've got a positive gradient, and you can actually tell that because the line's moving in the positive direction. Anything that moves upwards like this means it's moving positively, and we've tracked a positive movement, and we always work left to right, so that's, you can tell if it's positive or negative. Okay, let's have a look at another one. Now we've got this one. Now you can choose the intercepts as well, the 2 points that you're going to look at. So because it's clearly, we've got 2 intercepts marked here, and I only had 1 intercept last time. Well, I had 2, but I only used 1 of them. But if you want to, you can choose the intercepts as the 2 points that you're going to use to calculate rise over run. But you don't have to, so remember that, because I didn't use those in the first one and we still got a perfectly good answer, but I'm going to use the intercepts in this case. So run first, horizontal movement, 1, 2, each one's only 1, so our horizontal movement is 2, and our rise is actually going to go down, so that means we're going to have a negative value, but it's still considered the rise. So 1, 2, 3, negative 3. It's down, so it's negative. So in this case, our gradient is going to be negative 3 over 2, or negative 1.5. It's a negative gradient. And we can tell that also because our line's heading down in the downwards direction, negative gradient for our line. Okay, hopefully that makes sense. So the very last thing I wanted to show you here was that gradient can also be found without even having a graph at all. And if we've just got 2 points, we can find the gradient between them. So of course, if we had 2 points, we could plot them and draw them, but we don't have to do that to find our gradient. So we've got these 2 points, A, which is -3 and 6, and B, which is 1 and -3. And we can use the rise over run formula, or you can also write this as y2 minus y1 over x2 minus x1. And all this means is that it's the difference between our y values and the difference between our x values. But this is a really good formula that's going to help you. Now, x1, y1, x2, y2, what do they mean? So this just means we've got x and y values here, and these are our first ones. And we've got x and y values here, and these are our second ones. And it doesn't matter which order you do them in. You can do them, swap them around, and you'll get exactly the same answer. If you don't believe me, give that a try. But once you've got this formula, you can just substitute these values in. So y2, our y2 value is -3. Our y1 value is 6. Our x2 value is 1. And our x1 value is -3. So substitute that into that little equation and simplify. -9 over 4 or -2¼ could be your answer. So this is very, very useful formula to learn. You're going to use it lots more next year as well once you hit 10 advanced, because that's the type of you really use that more than rise over run as you get further into more advanced maths. So hopefully that one makes sense as well. Any questions, make sure you see me. So just a couple of little diagrams down here. Now we talked about positive and negative gradient, and you can see there's some diagrams there that may help you understand that. And we've got another diagram over to the other side, which actually has a whole lot of gradients on it. So if you have a look at this diagram on the right hand side, we can see we've got a line that's got a negative gradient, and it starts at the top and it heads downwards. So that's how you can tell it's negative. That's the blue line here. We've got a red line here that's got a positive gradient. It starts at the bottom and heads in an upwards direction like we had before. We've got another one that's got a 0 gradient. So that just means it's flat. It's horizontal line. And the gradient at that point is 0. It's not going up. It's not going down. And then we've got this other one, which you won't use too much, but it's called an undefined gradient. The gradient changes all the way along the line. So it hasn't got one particular value that we can list as a gradient. So it's listed as undefined, and you don't really need to know lots about that one. But if you understand how gradient works, it will help you understand the work. Okay, that is it. So exercise 4D and the questions that are set here are what you're working on now. So give that a try, and I'll see you in class.